basically describe a quantity, right? So not chemistry law or anything. We'll be using physics law. So that's why that quantity should be following the physics law. Is that clear?
So
Chalo, that's great. Just a second. So let me write down the physical quantity. Please. So first of all, a physical quantity that can be measured. Quantity that can be measured. In term. Of laws of physics are described as called uh, clear Sannidhi. Chicken. So that's what. Chicken. So quantity could be like we have like multiple quantities like mass, length, yes or no?
yes, sir.
Sure, that's great. Example could be length.
So will you tell me what you're writing?
Is it not visible to you?
It's visible. Do
Hello.
I write it? Will you tell me what
Yes,
to
you
write?
have. Yes, yes. You have to write all the things that I'm writing so far. You have to write it on your copy. These are the notes that you have to write in your copy. Chicken, length, mass,
Yes, sir.
time, force, etc. Chicken. So these are the quantities which follows the physical laws, right? And in these quantities can be measured. Chicken. Sure, that's great. Done. Hey, Sannidhi, your video is lagging.
Yes, sir.
It seems like you have network issue. Hello. Sannidhi, please check your network.
Yes, sir.
Yeah. So, yeah. Next thing
I'll
is,
check it.
yeah, please check because it seems like your video is lagging and your voice is lagging as well. It's like completely frozen. Yeah, now it's fine. Okay. Next thing is, Sannidhi, why do we need comparison? Okay. What is basically the process of measurement is basically a comparison process. Okay. So we are the process of measurement is basically of comparison. Okay. And comparison is done with the help of you can say unit. And okay, a unit is basically a kind of measurement of quantity which is accepted internationally, right? So we have meters that is accepted internationally. All the length that we measure is basically in meters. Mass is measured in kgs, and time is measured in seconds. So this is accepted worldwide. That's how the unit is basically comes into the scenario. Okay. So C point is an arbitrary. This chapter is a little bit theoretical in the start because it's have all the theoretical topic, and but in the later part of this chapter this is a little bit more numerical. Okay. So an arbitrary chosen standard measurement of quantity is accepted internationally.
So what's the word of the and?
Standard and arbitrary, arbitrary assumption kind of thing is called a unit. It's called unit unit of a quantity. Okay. That here.
Yes, sir.
That's great. Okay. Okay, so do you know what is mass basically?
So the weight of the object.
No, mass is different. Mass is basically, you can say the quantity of a body. That means what matter is there in the body, right? So we'll be talking about what is mass, like mass, length, time. Okay. So now let's talk it about. So first point is your mass. So in the 9th standard, there was a topic called weight and mass in the gravitation chapter. So there, the mass was introduced. Okay? So that's what I'm writing over here. So mass of a body okay, is defined. Just a second. Is defined as the quantity of matter in the body. Okay? And this mass of a body can never be zero. If a body is there, obviously there would be some mass which can never be zero. Second is length. So these are your quantities, the fundamental quantities. I'll discuss what fundamental quantities are and what is derived quantities. Okay. So the length is so length in simple words you can say that you can say the separation between any 2 points. So if you say that, right? So if I draw the graph, the line, just give me a second. If it so if we say that, what is the length? Okay. So it would be point A. So whatever the separation is there between the point A and B, that is called length. Yes or no, Sannidhi?
Yes, sir.
Okay. So length is the separation between any 2 points. Okay. Defined. Distance. Separation between any 2 points. Okay. Extreme ends of the object. Next is their time. So in simple words, what is time, Sannidhi? Time is, you can say that a clocks that basically time is a thing that clocks read. Chicken. Or you can say that time is a, you can say duration between any two events. Like suppose that if I'm speaking something, the next event that I will, the next word I will speak, the duration between that those two words can be considered as a time. It's basically a kind of duration or an interval. Okay. That's what, because a specific definition is not there for time and you don't have to define it, but I'm telling you just for the knowledge purpose. Okay. Time is a measure of duration of any two events. Okay. Relation between occurrence of. Is that clear, Sannidhi?
Yes, sir.
That's great. Okay, next thing that we have is basically the fundamental and derived units. This is one of the most important thing in the, you can say in this chapter. So we have to assume that which one is derived unit, which one is fundamental unit, right? So that's what we are gonna do. Okay. Please note it down. Let me know once done.
Yes, sir, I did.
Did? Chalo, that's great. Okay. Next thing that we have is fundamental units and derived units. What are fundamental units? Fundamental units, we have time, length, and mass. Those these quantities, okay, we basically see this thing as fundamental units, okay, or you can say quantities. So quantities would be time, length, and the unit is basically your seconds, kg, and meter. Is that clear?
Yes, sir.
Okay. The units of measurement of length and time are called. Stick it. Next point is the units measurement other quantities. So which can be obtained by add, like basically you have to divide or multiply. So this depends. Okay. So multiple quantities can be obtained from the fundamental units, right? Just like that, speed, distance by time. Two units, two quantities are used, but the new quantity is speed. That is different. So that is a derived unit. Okay. So the quantities that is made by the fundamental quantities are called derived quantities, and the units are called derived units. Okay. Clear, Sannidhi?
Yes, sir.
Obtained by suitable multiplication or division of powers of fundamental units are called derived units. Clear, Sannidhi?
Yes, sir.
That's great. Please note it down and let me know once you.
Yes, sir.
Done?
Yes, sir.
Check. Next is, okay. Just wait. So now let's come to the part of the standard, basically basically the choice of the units, right? So unit should be, so we have different things to consider. Unit should be constant, right? It should be of suitable size. It should be defined accurately and easily accessible. So these are the things that we should consider before choosing a unit, right? So that's why we have we can say that. And one more important factor is the international acceptance of that unit, right? So if a unit is there, so it should be internationally accepted. So such things we have is basically, so we have three types of systems in our, you can say, measurement. That is FPS system, ECGS system, or MKS system. And MKS system is generally considered as the SI unit system. Clear? So now let's note it, write it down. Okay. So A is your FPS system. Okay. FPS. So FPS means foot, pound, and second. So foot is for the length, pound is for the weight, and second is for time. Okay. So it's basically kind of in British system because foot is used and pound is used in the British, you can say countries, right? So that's why it says foot length is your foot, not the your food feet, not that one. It's foot kind of measure length. Okay. Pound mass, pounds, chicken, and time. Chicken. B part is your CGS, centimeter, gram, and second. Centimeter CGS system is considered like the smaller sister of MKS system. Okay. So it's very similar. CGS system. So length is centimeter. Okay. Mass is grams. Okay. And time is seconds. So time is the, you can say second is the only like is the only quantity or the unit, you can say that, which is considered basically, which is measured in same unit, right? Seconds for every case, whether it's FPS, whether it's CGS, or whether it's MKS. Okay. C part is MKS system. Meter, mass is kilogram, time is second. Any doubt so far to you, Sannidhi, in this?
Sorry?
Any doubt?
No, sir.
Yeah. So main, so you can say the main advantage of the MKS system is it is much more, you can say convenient because the sizes are very, you can say simple. But in the CGS system, gram is a very smaller quantity because ultimately we don't measure anything in grams. We most of the things in the basically in the surrounding is in kgs, somewhat like 1 kg, 2 kg. Right. So that's why MKS system is much more, you can say convenient, and that's why it is considered as the SI unit system. Is that clear? The international system. Okay. So this is your international system. Is that clear, Sannidhi, now?
Yes, sir.
That's good. Okay. So ultimately in MKS system, there is one more quantity called, so because we have extended the MKS system to the current. So that's why after MKS, A is also used for the current quantity, that is ampere. So we'll discuss it later, but ultimately MKS system is the general system that we use. And if you add it A, so your current will be included in that. Okay. That's great. So we have basically 7 quantities, those basically the 7 fundamental quantities, right? Mass, length, time, and current, and your temperature, and your luminous intensity, and matter, quantity of matter, that is mole. In the 11th standard, you like chemistry, it's very common, mole of a, you can say substance. That is 6.03 into 10 to the power 23 molecules, right, or particles, Avogadro's number. That's what mole is, right? So we have 7 quantities. That is your base quantities, or you can say the fundamental quantities. Apart from these 7 quantities, there are 2 more quantities that is also called supplement physical quantities, radian and steradian. Okay. So radian is basically the angle of a circle's plane angle, and steradian is a solid angle that is between the 3D object. Okay. So let me write it over here. Quantities. Okay. So first we have is your length. Okay. So mass, length, let's take mass. So mass is measured in kgs. Okay. Second is P, that is length. Length is measured in meters. Okay. Next is we have your time. Time is measured in seconds. That is small s. Okay. And next is your temperature. That is, so this is C. Temperature. That is your measured in Kelvin. Okay. Next is E. That is electric current. Okay. That is measured in ampere. Next is we have luminous intensity. Okay. It's also currently a fundamental quantity that gives the idea that how much bright the object is, okay, or any source of object. So luminous. And this is measured in candela. It's measured in candela. Okay. Last one is quantity of matter. That is your mole. Is that clear? Please do let me know.
So can you please explain luminous intensity again?
So
What do you mean?
luminance intensity is basically suppose that an object is there, source object, right? So it is emitting some light, right? So the unit that we use is your candela unit. Basically, suppose that there's some bulb. So basically, luminous intensity, which is you can say that an object which has its own, you can say, source of you can say light, just like the sun, right? So that's what luminous intensity is. Okay. And quantity of matter means suppose that an atom is there and material molecule is there. So the number of molecules in that is your mole. Okay. Quantity, how much quantity is there in a single mole. Okay. That's what matter is, this mole. Okay. Please note it down and let me know once done. Just give me a second.
Yes, sir, done.
Give me a second, Sannidhi, just give me a second, okay? Okay, Sannidhi, that's good. Acha, last is basically to supplement angle are so or basically quantities are also there. F G, you can say H is plane angle. Okay, that is your radian. Okay, radian and H, and this is solid angle. Because these two angles will not be required that much, so we are not going to into the depth. Solid angle, that is just radian. That is your S R. Is that clear, Sannidhi?
So,
That's great. And we have multiple quantities that is derived, right? So it could be force, right? It could be speed, it could be velocity, it could be power, it could be any, like apart from these quantities, any quantity that is present, that is your, or you can say the fundamental quantities, right? Any quantity apart from the fundamental quantities are called derived quantities. Okay? That's great. So just let me give you an idea what is radian or what is radian basically. Suppose that this is, so basically this in simple words, you can say that the angle between the arc. If there are two arcs right there, okay, Sannidhi. So the angle between the two arcs will be considered as the, just do this. This is this angle. This angle theta is your radian. Okay? The plane angle. The angle between the two arcs. Clear? So just a second, and because the drawing of radian is a little bit difficult, so let me show it to you as well like this. Check it. This is radian. Okay. Just a second, let me erase this thing and paste the picture as well. So this is your radian. So this one is your radian, this one is your radian. Clear, Sannidhi?
so
Please draw this figure and let me know once done. Done.
Yes, sir.
Now we have some units as well that is bigger than the normal units. That is called your practical units, basically. Okay. Some important practical units that is used in space, you can say space terms related, right? So the first unit is your, okay. So let me write it down over here. So the first is practical units. So the first unit that we have is light year. Okay. So first let's take astronomical unit, that is AU. What is it basically? It is the average distance between the sun and the earth. Okay. Clear? And what if it's if we talk about a number, so it would be equals to, so it's very important, 1 AU, 1 astronomical unit is equals to 1.496 into 10 to the power 11 meter. So, or you can say that approximately 1.5 into 10 to the power 11 meter. Okay. So that's the astronomical units. Next is your light year. So light year is basically the 1 light year is the distance traveled by the light in 1 year. Whatever the distance the light will travel in 1 year in the vacuum, that is your light year. Okay. 1 light year. Distance traveled light in vacuum in 1 year. Okay. So this is equals to somewhat 9.46. 1 light year is equals to 9.46 into, it's also 10 to the power 15. Okay. So you can say that it's almost, it's also 9.5 related. You can say it's also 9.5. Okay. So these are some things that we have discussed so far. Please do let me know, Sannidhi, is that clear to you or not?
Yes, it's clear.
That's great. Okay. So in the next class, Sannidhi, we'll just complete this thing, and after that, we'll discuss about more related to the basic quantities, how to get the You can say the normal quantities, dimensions, and the units. Okay, derived quantities. And after that, we'll discuss more about that. Is that clear?
Yes, sir.
That's right. So with this, just end this class. Okay. So in the next class, we'll discuss more. And apart from that,